Hello and welcome back to our lecture series on two-port network. So right now we are going to be learning how to solve questions on Z parameters. Exactly. So this is the first examples. In the first one we've talked about more like an introduction to what Z parameters and the equations and formula that is associated with it. So now let's look at how to solve questions that deals with Z parameters. So let's look at this question. It says, determine the Z parameter for the circuit in the figure below. Exactly. So like I said in the other part of this, in the previous parts, I mentioned that you can see that this question says determine the Z parameter. So some can tell you determine the open circuit parameter. Some might just tell you determine the impedance parameter. Exactly. So that's why I said you need to get yourself familiar with the other terms for each of those parameters. Exactly. Okay, so since we have it like this, so the way I like to do mine, so let's go ahead and solve this. So he said determine the Z parameters for the circuit in the figure below. So basically what they're asking us to look for the Z parameter is for us to look for the value of Z11, Z12, Z21 and Z22. Z22, exactly. So these are the Z parameters that they're asking us to look for or to determine exactly in this question. Okay, so for us to do this, so let's have our solution. So first thing I like to do is I like to redraw the circuit to have it like a normal circuit. So redrawing it, I'm going to be having something like this. And then here will be the branch for the 6 volts. I mean 6 ohms. Okay, so for the V1 here, so we'll just have it as V1. Exactly. So okay, the question will give the polarity for the voltage source. So this is positive, negative, positive, negative. So, and I've replicated it that this longer side represent positive and shorter leg represent negative. So I'll do the same thing here. So positive, then negative. Okay. So let me also add the values. So this is 6 ohms, this is 3 ohms, and this is 12 ohms. Now, like I said, you need to pay attention to the polarity. If you look at it, the question, the polarity is already given. This is towards this direction. Exactly. So that's the direction I would also like to assume to avoid any form of mistake. So that means this is the direction here for I1 and this is the direction for I2. So what I'm going to be doing next is I'm going to be solving this circuit using mesh analysis. That is the Kirchhoff voltage law. Exactly. So in doing that now, so that means I'm going to be having mesh 1 and mesh 2. So since we already have a direction for current, I'm also going to take that direction. I'm not going to use another different direction. So that means the direction is going to be like this for our I1. And then in our mesh 2, since we already have a direction, so I'm going to be using that same direction, which is B for our I2. Exactly. So this would be my mesh 1, and this would be my mesh 2. So based on the direction that I've taken now, so let me just give polarities to the resistors. So this is the plus and minus. So in this direction, this will be plus and then minus. This will be plus, minus, plus, minus. So now let's do some mesh analysis. So let me say, so if I should say apply KVL to mesh 1. So what I'm just doing now is mesh analysis. Exactly. So if you don't really understand mesh analysis, you can just follow along. I believe you get the concept, or you can just check the playlist. Exactly, I've done a video explaining mesh analysis. So in doing this now, if you should go in this direction like this, so that means our V1 will be positive, so from negative to positive, so that will be V1, and then from positive to negative due to I1, so that will be minus 12 I1, then from positive to negative also, so we are done with that 12, so that will be minus 6 I1. Also we have positive to negative due to I2, so that would be minus 6 I2, and then I think that's all for this mesh 1, then equals to 0. So what we'll do now is to tidy up the equation. We are going to be having V1 minus 18 I1 minus 6 I2 equals to 0. Okay, so one thing, like I said in the previous video, take note of that formula. Let me just write it here, where we have our V1 is equals to Z11 I1 plus Z12 I2, and then we have our V2 to be Z21 I1 plus Z22 I2. So now what we want to do here is we are going to rearrange it so that V1, such that it will look like this. Very good. So that means if you say V1 is equals to, so if you bring this and this to the other side of the equals to sign, it's going to be equals to 18I1 plus 6I2. So this is our equation 1. So take note of this. Also, if you should apply KVL to mesh 2, so this is our mesh 2 now. So if you look at the direction, and this is the direction that it is going for the current. So this is our V2, this is our positive, negative. So let's just start from there. So that means we are going to be having V2, because from negative to positive. Then, so this is the next element component there. So from positive to negative, that would be minus 3 I2 minus 3 I2 from positive to negative for the 6 ohms. So that will be minus 6 I2, also positive to negative due to I1 current. So that will be minus 6 I1, and I think that's all, equals to 0. Okay, so let's also tidy this up. This will be V2 minus 9 I2 minus 6 I1 equals to 0. Okay, so this now we can write this to make it look like this. So that means V2, if you make V2 to be alone or the subject formula, so we are having V2, that means we are taking this to the other side of the equals to sign. So that means our V2 will be equals to 6 I1 plus 9 I2. So what we are having there will be our equation 2. So take note of this. Okay, so now if you look at what we have, our equation 1, and so let me call this equation 3, and let me call this equation 4. Remember, this is the Z parameter equation, exactly, so it's not something new. So if you should compare what we are having in equation 1 with what we are having here, I hope you are seeing it. So okay, so if you compare what we are having here, if you are comparing what we are having here with this, you see that there's similarities there. Exactly, so this is V1, this is V1 equals to 18I1 is equals to Z11 I1. So that means we can, by comparison, so that means our our Z11, so let me just write it now. So let me just write the V1. So that means our V1 is equals to 18I1 plus 6I2, and then our V2 is 6I1 plus 9I2. Okay, so I said if you look at it side by side with V1 equals to Z11 I1 plus Z12 I2, then V2 is equals to Z21 I1 plus Z22 I2. So if you look at them side by side, so if you look at this with this, so we can conclude that our Z11 is what? Is 18. Look at it. That means our Z11 is 18. Exactly. So then our Z12 is equals to 6. This our Z12 is equals to 6. Then our Z21, this our Z21 is also equals to 6. And then our Z22 is equals to 9. And with this now, we've been able to answer the question, because that's what the question is asking us to do. To find the Z parameters. And don't forget the units. to be in ohms. So this is how you answer questions under Z parameters when you're asked to find the Z parameters. Exactly. So don't worry, we are going to be looking at more examples, exactly, because some can get more complicated than this. But it is good that we start with some more basic examples, exactly. So with this now, we've been able to determine the Z parameters for this particular circuit or the particular figure. Exactly. I hope you get the concept right. So if you find value in this example, please give the video a thumbs up. Do make sure you like and then you share the video. And don't forget, please subscribe to the channel if you are yet to. Are we good? If you have any question, just let me know in the comment section below. So with this, I'm going to see you all in the next example under Z parameter. Thank you very much.